Hello students, my name is Surya Prakash Pandey and today we are going to solve linear differential equation of order 1. So standard linear differential equation is of the form of dy over dx plus py equals to q. Note here pq are either constant or a function of x. We can also rewrite this equation as y prime plus p sub y equals to q. Remember, pq are either constant or a function of x. So in order to solve this linear differential equation, first of all, we find integrating factor, which is equal to e raised to the power integral of p dx. Please note here we do not add constant of integration. Now, solution of given linear differential equation is y times of integrating factor equals to integration of q times of integrating factor plus constant of integration. So please note down, linear differential equation is of the form of dy over dx plus p sub y equal to q, where pq are function of x or a constant. First, we find integrating factor, which is equal to e raised to the power integration of p dx. Now, solution of this linear differential equation is y times of integrating factor equal to integration of q into integrating factor plus constant of integration. Or we can rewrite this solution as y equals to 1 over integrating factor into integration of q times of integrating factor plus constant of integration. So let us solve couple of examples so that we are able to understand linear differential equation properly. So in the first example, suppose our equation is dy over dx plus py equals to e raised to the power minus 2x. So compare this equation with dy over dx plus py equal to q. We get p equal to 3 and q equals to e raised to the power minus 2x. So let us find integrating factor first. So our integrating factor is e raised to the power integration of 3 dx. So it becomes e raised to the power 3x. Now, solution of given linear differential equation is y times of integrating factor equals to integration of q times of integrating factor plus constant of integration. So let us put the value of q and integrating factor. Here q is e raised to the power minus 2x. Integrating factor is e raised to the power 3x. Here y times of e raised to the power 3x. This is e raised to the power x dx plus c, y times of e raised to the power 3x, which becomes y times of e raised to the power 3x equal to e raised to the power x plus c. This is our general solution for given linear differential equation. Let us see one more example to understand it better. So this time, our differential equation is dy over dx plus 1 over x times of y equal to x square. So let us compare given differential equation with dy over dx plus py equal to q. So we get p equal to 1 over x and q equal to x square. So integrating factor is simply e raised to the power 1 over x dx, which becomes e raised to the power ln x, which becomes simply x. Now, solution of given differential equation is y times of integrating factor. So let us write y times of integrating factor equals to integration of q into integrating factor plus constant of integration. So let us plug the value of integrating factor and q. So q is x square, integrating factor is x plus constant of integration. Here integrating factor is x, so y times of x equal to this much. So y times of x equal to integral of x cube plus constant of integration, which becomes simply x raised to the power 4 over 4 plus constant of integration. This is the solution of given linear differential equation. Let us see one more example to understand linear differential equation. Suppose we are finding solution of dy over dx plus 2x upon 1 plus x square times of y equals to sine square x over 1 plus x square. Now compare this equation with the standard linear differential equation. We get p equals to 2x upon 1 plus x square and q equals to sine square x upon 1 plus x square. So let us find integrating factor first. So integrating factor is simply e raised to the power integral of t, which is nothing but 2x upon 1 plus x square dx. So this term becomes e raised to the power ln 1 plus x square. And this becomes 1 plus x square, since we know e raised to the power ln fx is simply fx. So now let us solve the given linear differential equation. So solution of given linear differential equation is y times of integrating factor. Here we write integrating factor directly. So integrating factor is 1 over x square equal to integration of q. So q is simply sine square x over 1 plus x square into integrating factor, which is 1 plus x square dx plus constant of integration. This time 1 plus x square get cancelled. We can rewrite sine square x as 1 by 2, 1 minus cos 2x dx plus constant of integration, and this is y times of 1 plus x square. Now integrate right hand side, we end up getting 1 by 2. Integration of 1 is x, integral of cos 2x is sine 2x over 2 plus constant of integration. So this is the final solution of given linear differential equation. Similarly, we can solve any linear differential equation by finding simple integrating factor and then using this simple formula. Hopefully you find it helpful. Thank you.